All right, perfect. Hey everyone, welcome to Fundies 1 exam review. So before I start, one of the most frequently asked questions to like just me or any other TA is like, how do we kind of prepare well for the exam? Or do you have any tips for the exam? And sorry, give me a minute. Yeah, sorry. The common question everyone asks us is like, how do we prepare for the exam, or what do we do to ensure everything goes well in the exam? And one of the only suggestions I would give is follow the design recipe, because when you follow the design recipe, you're more likely to like follow all of the steps and get things correctly. Furthermore, if you don't really know anything during like in the question, there is always scope for partial credit. So you get points for like writing signatures, purpose statement, tests, code, and so on and so forth. So by following the design recipe, you're ensuring you're attending to those partial credit questions and you're able to get something, even though you might not know how to solve an entire solution. So yeah, just follow the design recipe and it will hopefully go. So in today's session, what we would be kind of doing is we'll be covering structures and list everything from the scratch, just so that anyone who may not know how it works, they kind of get to know everything, the syntax and what all recipe elements are there along with that. And then once we kind of go over these topics, Ryan and David are going to go over the exam, and then we'll finish it off by giving away extra tips for the exam to kind of help you do better in the final exam. Cool. So the first problem we're going to deal with is Dunder Mifflin accounting problem. In this, we're going to cover normal data structures and union type data structures. So let's look at the question that we have kind of in front of us. Dunder Mifflin has three types of employees: salaried, hourly, and temporary. Salaried employees have a name and a fixed salary for a given year. Hourly employees have a name, hourly rate, and the hours they have worked in a year. And temporary employees just have a name. They always get a salary of $12,000. So the job over here is to design the data definition for Oscar to store all of this data. So the main reason this is going to be a union structure is because if you think of it, an employee can now be one of the three types. It can be a salaried structure where the information that we're storing, salary in a given year. They can be an hourly employee where we are storing the name, the hourly rate that they're working, and the total number of hours they're working in a year. And temporary employees, since they're just storing a name, we can kind of go with a string and define the salary of $12,000 as a constant so that we can kind of use that later on. So, oops. So let's go ahead and kind of design the structures of all of these three options. So the first thing we know is we have to design a structure where we're looking at salaried, temporary, and I'm going to start with the salaried data structure. So one of the things about structures is we use the define struct keyword to make a specific structure. The structure has a given name inside of it, and then it has multiple fields, or as we can call it also, selectors that kind of go over here. These are essentially what informations is the structure going to store. And when you make a specific structure, you have a couple more things. One of them is called the constructor, which is something like make with the name. It creates an instance of that structure. You get selectors where you can use the name of the structure dash a selector name and extract that given information. And you get structure ha. So in this case, something like name ha, which tells you that if something is a type of a structure or not. So let's design a structure for salaried first. So the first thing we would be doing is we would have the define struct. In this case, our structure name will be salaried. So salaried. And we have two specific fields, the name field and the salary field, right? So the first thing we have to do when we are kind of writing the data definition for this, when we're creating a new data, is write the data definition for this. And the way we write the data definition is we essentially do a salaried, which is the name of this specific structure, and ensure that you're using a capital letter because that's used to indicate a data type. A salaried is a make salaried, which indicates the constructor that we would need to create this specific structure, along with the types of name and salary. So let's say this the name would be a string, and salary I'm going to go with, let's say, a positive integer. The next thing is the interpret. So the interpretation would look, the interpretation pretty much explains what the structure is as well as what the fields are. So it represents a salaried employee where name is the name of the employee and salary is the annual salary of an employee, right? The next thing we would do is write a couple of examples of this. So the way we would write examples is we would have, let's say, something like define Michael, that is a make salaried, where we go with Michael Scott. Let's say I'm going to go with like 55,000 as a salary. And that's like one of the examples of how you would write Michael. And the last thing we want to do is we want to write the template for this structure. So always remember that when you're kind of writing the template, the name of the template doesn't make a difference. You can name it anything. So in this case, I'm something like sal-temp. And this salary template is going to take in an entire instance of a salaried employee. So it's going to take in a salaried, and since it's only a template, we don't know what it's going to return. So it's going to have like the unknown return type. And so when we go ahead and kind of define the template, we're going to have salaried template that's going to take in a salaried employee through this variable called S. We know we have to do something on top of all of the selectors of the salaried structure. So we would have salaried dash name of the S and salaried dash salary of the S. And since both of these are atomic data types, so string and posint, we don't need to kind of break it down further. But if any of these two were like custom data types, what we would have to do is essentially call another template onto that so that you can kind of break it down further. So similarly, we would be designing the, what's it called? The hourly structure as well. So I'm not gonna spend a lot of time because it's essentially a similar concept. So we're gonna have a defined struct hourly, which essentially has a name, rate, and the total number of hours. The name is going to be a string again. The rate is going to be, let's say, a posint, and hours is going to be posint again. Example of this specific structure would be Daryl. And just remember when you're defining like constants to have the naming convention as all caps. And since our structure is called hourly, we're going to have a make hourly with Daryl. His hourly rate is $18 and he worked 3,056 hours in a given year. And the template would essentially look something similar like the salaried one, where it's essentially going to take in an hourly employee. It's going to extract the name, rate, and the hours, and so on and so forth. Cool. And the last one which we had was the temporary employee. And since we can kind of use string to represent an employee, we don't really need to create any other new piece of data. We can just have a constant. So define temp salary as $12,000, and we can kind of keep it just for now so that we remember, like in the future when we kind of have to use it, um, we can figure out like how to specifically use it. Okay, couple of questions that came to me in a private chat. Okay, so just letting you know, please don't send me private chat, because like I won't be able to like respond to those, like, and David and Ryan can respond to those. So like if you put it in the general chat, David and Ryan can definitely reach out again. So one of the questions was, do we always need the signature for the templates? No, you don't really need the signature for the templates. The only reason I put them is because a lot of times people get confused about what type of data is this S. And so the only reason I'm putting a signature is to indicate that we're going to get a salaried employee, and templates don't give out any form of output, because a lot of time people would have like output inside the template as well. And so you kind of want to avoid it. The second question was, does it matter where the ellipsis goes in the template? It doesn't really matter. Essentially, the ellipses are just to kind of indicate that some function is required. So the way I usually go about it is I open a bracket and then I put the dot, 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 and then I just continue with my work. A lot of the times, I know the class follows something like this, where it's like they have something in the start and something afterwards. You could do that, but like I have never deducted points for not, like, having less number of dot dot dots or having low number of dot dot dots. So the style I usually prefer is just like wherever I would potentially need a function, I put a dot dot dot. Otherwise, I just kind of go about doing it. The next question is, what about the parenthesis? Okay, so Ryan answered that. What about the parentheses? So are you asking like the indentation thing, or?
I think the question is like will you lose points on the exam if you have like issues with the parentheses, like you're missing one or like you didn't do it correctly?
Yeah, you wouldn't lose points. Yeah. And do we only bring a pencil and our piece of paper to the testing center? Yes. I mean, if you can bring multiple pencils and multiple pens, but apart from that, I don't think you'll need anything else, and your notes, obviously. Is the recording going to be posted on Piazza later? Yes. If we know what type salaried name is, why don't we use string equal huh? So we don't really know what we want to do with the salaried name, right? Like my job could be to calculate the entire length of the string, right? And so if I'm calculating the length, string equal huh is not going to help me with that. Similarly, if I just want to figure out, well, if I want to figure out if the name is a string or not, I would be using string huh. Like I wouldn't be testing that in a real world scenario because I've specifically stated that my name has to be a string, but I'm just giving an example. So we don't know what specific function would be assigned to this data type. We can potentially do a lot of things with this data type. And so that's why we wouldn't be using a string equal huh in the templates over here. For templates for enumeration data, do we need to put the first part? For enumeration data, I'm going to move forward on another example and we'll talk about it. That any restrictions on notes page? No, you can write as much as you want, and you can write as small or as large as you want. Can the cheat sheet paper be front and back? Yes. Will there be scrap paper provided? I don't know that. I would ask that on Piazza, because it's a little bit dependent on professors. Like, since, okay, so usually when I have done in-person exams, the last one or two attached pages are just like rough pieces of pages. You can't remove them because those need to be submitted as well. So you can do rough work, but you have to submit them. However, I will want to like confirm it on Piazza, mainly because it's been a long time since we did in-person exams. And so this information can be inaccurate because I did this course in like 2018. And so it's been like a very long time. Okay, cool. So if any questions come up, Ryan and David, feel free to answer those. But I'm just gonna kind of continue with the thing. Okay, so the next thing is looking at the enumeration style data, or the union data in this case, because it has to be one of multiple things, right? So over here, what I would do is I would have a separate data which says an employee is one of, and I will say three specific things. It can be a salary, it can be what's it called, an hourly, or it can be um, a string, right? And essentially this represents a type of employee. So a couple of examples for this would, I'm just gonna steal the examples from here because I don't wanna make more, but we're gonna have like Michael for the salaried example, we're gonna have Daryl for the hourly one, and we're gonna have define Ryan as just cool. So those are the three types of employees we have. And this is where we kind of get to the enumeration slash union style of data. So if ever you encounter this situation where you have something like a structure is like one of multiple things, it's very clear that we have to use a conditional because we want to check for multiple things, right? So let's say employee template takes in an employee, and we know it doesn't return anything specifically, right? And so I would have define employee template that takes in an employee. And the first thing I know is I have to do cond, and we will have three specific conditions, one for salaried, one for hourly, one for string, right? Now, since salaried is a specific structure, we also have the option of um, the structure that we spoke about, which in this case is going to be salaried. So essentially what salaried will do is it takes in one specific thing and it determines if it's a salaried structure or not. So we're going to have salaried e, and if it's a salaried employee, then what we want to do is we essentially just want to call the salaried template. So we want to break it down so that a helper function would potentially handle whatever functionality there is regarding a salaried employee. So we would just do sal-temp of e. And similarly, the hourly one would have something like hourly e. We would do, what's it called? Hourly template of type E. And the last thing we would be doing is we would be checking string E. And since string can't be broken down, we're just going to have dot dot dots over here. Or in some cases, I have seen something like this also. Both are fine. Like, I don't think those are like very big things. One of the things you just want to notice is I didn't use string equal I used string and the reason I use string is okay, let me run this one so that I can demonstrate. So if I do string equal Michael with, let's say, hello, it's gonna give me an error where it says expects a string given a make salaried employee, right? And so string can't give you like a true or a false if you give it a structure or if you give it any data type which is different than a string. But if I do string of Michael, I'm Oh, I spelled it wrong. Ha of Michael. It's going to give me false because Michael is not a string, right? And similarly, if I was to do something like salaried of Michael, it's going to give me true because Michael is a make salaried, and a make salaried becomes true for the salaried thing. So that's kind of how we would define the union structure. I'm going to take a pause at this point, and I'm just going to read through the chat to see if there are any questions you have. And once I've answered those, we can kind of move forward with that. Okay. Or David and Ryan, do you want to tell me like if there is any specific question that was unanswered, and I can go over those?
I think we're mostly caught up in the public chat. I'm not sure if one of y'all's questions wasn't like fully answered, feel free to just ask again. We can address it again.
Okay, can we not just call the specific selectors for each employee in the employee temp? Can we not call the specific selectors? Okay, got it. Yeah, I'm gonna address that like in 5 minutes about when we call the individual selectors here and when do we call the template, because there are two different styles of writing this specific thing. So just hold on to that. I'm going to address that. Is the practice exam we on here going to be posted on Piazza? So the recorded session of the practice exam, yes, that will be posted on Piazza. The solutions is something we need to like confirm with the professor, because in the past we haven't posted like the solutions of the practice exam online. But if the professor is fine, like I don't mind sharing the solutions. It's yeah. So it just depends on the professor, but if they agree to it, we'll definitely share it with you. Otherwise, you can definitely like go over all of the recording and kind of like copy paste it. It's a little inconvenient, but yeah, we just need to ensure that we are kind of authorized to do that. Cool. So the next thing is this can actually be written in another style. And I'm just gonna go and select like another tab just so that I don't mix up the stuff. So the second way I can kind of go about writing it is I can say an employee is one of, and instead of saying salaried, I can have something like make salaried important. I can have make hourly. What was the other one? Wasn't. And I would have just the thing to represent it. So the difference over here is, in this case, I have specifically defined these prior, right? And all of these have their own data definition, interpretation, examples, and template. And so these are kind of defined as like separate data types. And that's why I'm using salaried over here. In this case, we're going to have everything in this one specific thing. And so we are not going to have like those custom things defined, and that's why we are going to have like a make salaried such as this. So in this case, we obviously need the structured definitions, because otherwise we can't do the make salaried and make hourly. So I'm just going to copy the salaried and the hourly data structures. The next thing is the interpretation. So the interpretation is going to be represents an employee that is either salaried, hourly, or temporary, where salaried employees have a name and salary. Um, temporary employee, not sorry, not temporary, hourly employees have a name, wage, and total hours they work. And then the last thing is temporary stores the employees. So that's the difference between both the structures. So in one of them we have like the interpretation separately. In this other one we have like everything over here. And so the examples would essentially be the same thing. You would just have the same type of examples. uh, the difference is in this case, we are going to have a different style of template. So we're not going to have the same style of template. We, instead of these two calls, we're going to have all of the selectors come in over here. So what we're going to do is we're going to have, where's salaried? We're going to take this specific thing and we're going to have this like this. And similarly for the hourly one, we are going to copy this and paste it. So these are two different styles of writing it. Both styles are correct in a way. I would personally prefer the first one because you can like break it down further and like test different things. This is like a bit more complicated way of doing it. But usually like sometimes to kind of trick you, professors do give like this style of data definition, and they kind of expect you to write template which follow like this specific style. And so that's one of the main reasons I'm kind of covering it. Yeah, and that covers essentially the entire data design of the thing. So just to recap, the structure has a defined struct, which is a function to make a structure. It has a given name. It has different fields that we can also call selectors. Once you make a specific structure, you get a constructor which makes like an instance of a given structure. Selectors are able to like remove these specific fields out of a given structure, and structure ha, or in this case like whatever the name is followed by a question mark, can specifically help you see if something is a type of a structure or not. And potential things that I've noticed in like homeworks and previous exams is, if you're dealing with structures and you're making functions, ensure that you're giving it like one specific type of a structure. So salaried employees have like a name and a salary, and the name is represented by string and salaries by posint. But when you're providing it to a function, the signature is never going to be string posint or something like a name salary, because these are not even data types. It would be essentially the entire salaried structure to some specific output, where the salaried is something like a make salary dot dot dot. So Michael, when it's passed on as an input, that's an instance of a salaried employee. The next thing is people tend to forget what the data definition needs to have. They know that it's like make salaried, but a lot of the times you end up writing name salary instead of the string posint. So just to recap, over um, over here, when you're saying a salaried is a make salaried, you have to specifically give the type of these fields. So the name has string and the salary has posint. Don't write name over here and don't write salary over here, because those are not like data types. Those are just field names. Um, and the last thing is forgetting the variables. That's like a very common thing. So just remember, you open a parenthesis every time you try to call a specific selector. And I've also seen something like having salary dash name, but it needs to be of some variable, right? Because you can't just have salary dash name. So let's say if the s was the variable for the function, you would want salary dash name of the s so that you can extract that given information. um is this slide deck going to be posted somewhere? I will post this slide deck on like I'll put it in a Google Drive and I'll share it with you. I am allowed to do that. The only thing I'm not sure if I'm allowed to do is share the code from the practice exam. Because these are stuff that is like made by us and it has been just kind of like copied from the previous labs. So like we have the flexibility of sharing it. Exams are something we can't like share per se, and that's the only area where like I need to ask the professor before I do anything else. Okay, so and then recapping both the styles, one of the style was an employee is one of salaried, hourly, or string, where both of these are defined. The other style was a make salaried, make hourly, and string. In this, every structure will have complete design recipe at the top somewhere before you make this union style structure. And employee templates will have calls onto the other templates. And in this, you will only have the structure definition on the top. All of the design recipes will be along with this, and templates will have no calls to the structure. So just to kind of visualize it, in this case, the data definition is like this. There will be no additional interpretation. We just need to kind of like indicate that this represents an employee. We don't need to specifically talk about what the salaried, hourly, and temporary employees are because we have done that previously. In this case, we have to do that because we haven't done that previously. And the template will have template calls such as these. In this case, we have like all of the selectors being called on. Cool. Yeah. The next thing is a lot of people get confused between unions and enumerations, and I understand why. They're kind of like the same concept in a way, because enumeration is just like is a one-off dot dot dot. Unions tend to follow the same structure. There is just one difference between both of them. Enumerations focus on one specific data type. So let's say the people who did the traffic light example, right? A traffic light is one of three colors: red, yellow, or green. In that, all of them are the types string. But in a union structure, they generalize the types, which means you can have multiple data types. And so the reason the employee is a union data type is because we have salaried, we have an hourly structure, and we have a string structure. If at any point you see like is a one-off type definition, I got the spelling of definition wrong, it will always have a condition inside the template. So just remember, you ever see that, put a con by default. And within those structures, if a data is atomic, you don't need a template call. If it's not atomic, you want to have like a separate call to it. So if the data is a structure and it has its own data recipe, a separate call to the template is required. Okay. Before I move on, is there anything? Could atomic data be explained in a bit more detail? So atomic data is like, in a way, the smallest form of data you could have. And there are four types of atomic data: string, numbers, images, and booleans. So if you encounter any of those four things, it's like a type of data that can't be broken down further. So oops, sorry, I moved the wrong screen. In this case, since let's say a string is a type of atomic data, we're not going to break it down further. We're just saying that, okay, something needs to be done on E. But since hourly and salaried are not atomic data, they're kind of like broken down into like those individual templates. Yeah. And just another thing, if you have like a custom range of numbers or custom strings that you have, those need to be defined as a separate enumeration style data. So like, let's say if you were dealing with like numbers such as 40 to 50, right? You would say something like a custom num is a posint in 40, 50. And the square brackets indicate inclusive of. If you have curved brackets, it indicates not including. So if I had like curved brackets 40, 50, it means my range is 41 to 49. It does not include 40 and 50. And then you would just follow the same data design for like writing the interpretation, writing a couple of examples, and your template would essentially just look something like this because you can't break down a number more in a way. Okay, cool. And where's the chat? Do we need to write check expects? Okay, I think the rest of it is answered, so I can kind of move forward. Cool. So the next thing we have is making a function. So Oscar is the accountant. He often deals with employees' wages. Design a function that can take an employee and tell Oscar how much they earn annually in Dunder Mifflin, right? So the first thing we're going to do is we're going to write a signature, right? So signatures have the function name. So let's say I'm going to go with like year dash salary. Year dash salary is going to take in an employee and it's going to output a positive integer, right? The purpose statement is going to be essentially what the function does. One of the most common mistakes people make over here is repeating the signature. So at any point, you don't want to like repeat that it takes in an employee and returns a positive integer. I'm going to go with like determines the annual salary of a given employee. That's fine. But like if I like a bad purpose statement would be something like takes in an employee and gives a percent. That is essentially like repeating the signature and you will get points off for that. So you want to avoid doing that and just like briefly explain what your function is going to do. Cool. The next thing we are going to do is write check expects. So we would have check expect. The function name is called year dash salary. That's going to take in Michael. And if it takes in Michael, we want to return 55,000. And then similarly, if it was an hourly employee, okay. So so we know Ryan is going to return the constant amount, which is the temp salary that we have. And for Daryl, I believe the amount is just slightly that. We'll check the math later on. Cool. So these are the tests that we have kind of written, and note like one of the things that I've kind of done in the tests is essentially follow like cover all the cases inside my template. So I have one test for salaried, one for hourly, one for string. And that's like a good way of testing because when you're testing, you want minimum 2 tests if there are no cases. If there are like multiple amounts of cases, you want to come like write a test for each and every case that you have available over there. So like, let's say if I had like 10 different types of cases for this thing, I would have to write minimum 10 tests to ensure that I'm covering each aspect of the code. All right. So next thing is writing the specific code. So the best thing about the template is you're going to follow like this kind of a structure. And so I can just like copy paste this specific thing and we can kind of move forward from that point onwards. So I know my function is going to be called year salary. So let's replace that. It's going to be called year salary. Takes in an employee. If it's a salaried employee, we're going to call a helper. If it's an hourly employee, we're going to call a helper. Otherwise, we're just going to do temporary salary, which is the $12,000 thing. And similarly, just to kind of save on time, I'm going to skip a little bit of the design recipe for the helper functions because it's essentially covering the same things. But when you are writing this, you want to ensure that you're covering all the aspects of the data design, of the function design. So you I'm going to go with like insert sig statement tests. And then I'm just going to focus on the function for now. I'm going to do something like get salaried, and I'm going to call this get of e. Okay. And so essentially we follow the same structure where we take the entire salaried thing. It's going to be called get salaried. So get salaried gets a salaried employee, and we just want to return this specific number, which is their salary. So we get rid of all of this, and it just does salaried of like salaried employee's salary of the given specific employee. And similarly, when I design the hourly thing, I'm going to have this specific thing. We don't need to do anything with the name. So I'm going to get rid of the name. And to get an hourly employee's yearly salary, we just do multiply the hourly rate by the total number of years, not years, sorry, total number of hours they work in a given year. And that's going to be what my helper functions kind of look like. And so once I run this thing, hopefully, yeah. All of 3 tests passed over here, right? Which means it worked well and all of these were kind of correct. Yeah, and just to recap, I'm ignoring the design recipe over here just to save on time. One of the other things I would just want to mention is, let's say if you didn't write this specific check expect, right, you would get like this kind of highlight in on a computer, and this highlight indicates that something has not been tested in a way. So even though you don't, even though you have a paper exam, just ensure you're covering all of the cases inside a con, because we will require you to like test thoroughly for any given function. Okay. Instead of creating helper functions, is it also possible to pull out specific accessors? Yes. So in this case, since it's like a very simple thing where I'm just doing salary dash salary, you can do it over here. I chose not to, mainly because I wouldn't be following the template in a way. But for simple things where you're just doing like get salaried, you can just do salary dash salary of E. That's fine as well, because it doesn't change as much. Similarly for this, the only thing is, if you have like a data design such as this one, in this case, you wouldn't be making helper functions. You would have to like specifically do all of your calculations over here. So just remember the type of the data that you have. Uh, and in this case, if like we did like more complicated functions, then you shouldn't have like any specific stuff getting done over here. You should just do a helper function call and work from that point onwards. Cool. Okay, before I move to the nested and recursive data structures, are there any questions that you want me to potentially answer? Okay, if not, I'm gonna move forward. I personally wouldn't answer like any questions right now, like going back on the question. The TAs can do so, and I'll focus on like the question 3 right now. So in this specific thing, we kind of cover nested structures, which is like if there is a structure inside another structure, and how do we kind of deal with the design recipe for that, yeah, the design recipe for that. And then we'll kind of use that to move forward into the recursive data structures. So we'll look at the self-referential data structures, and then we'll move on to lists using the same. So in Friends, Phoebe has multiple pet rats in her apartment that she feeds at a regular interval. In this case, what we're going to do is assume each rat has a name and a feeding time, design the data to represent a rat. And I didn't want to write all of the stopwatch data structure just to save on time. So I have it like written down, and given that data, we're going to design a structure for a rat. So let me just copy it down from onto. Okay, so the data for a stopwatch is something like this. We are going to have a stopwatch, or in this case, I'm going to call it time. The time has the hour, the minute, and the second. And since all of these are like sort of custom numbers, right, in a specific range, I have like separate data for them where I'm saying an hour is an integer in 0 to 23 range. A minute is an integer in 0 to 59, and a second is an integer in 0 to 59. And then based on that, I have the interpretation for everything, um, the examples for everything, and the template for everything. And similarly, the structure would have like two examples, so like time one and time two, where we have like a make time representing the hours, and similarly make time representing another kind of thing. So in this, I've kind of like done two different styles. One is assuming you have like some form of constant defined up top, and the other one is like I'm just giving the data over here as well. The template would have just essentially this specific things where we are calling on to each individual, um, each individual fields. So let's move on to the design of a rat. So in our structure, we said that we're going to have this rat structure, which has a name and a feeding time, right? And so we're going to have the data definition, which is a rat is a make rat. Name will just be the string. Feeding time in this case will be a time, right? And so the time is essentially this specific structure, which has an hour, minute, and second. Then the interpretation will be like represents a rat with a name and feeding time, where name is the name, feeding is the feeding time, I guess. The example would be something like define rat1, let's say make rat Bob, and Bob will get feed at time 1. The other way I can define it is define rat2. I would have a make rat. Let's go with Stuart. And instead of having like a predefined time, I'm going to go with like something like a make time 2, 4, 5. So both ways are fine. This one is the preferred one just because you have like examples defined up top, and you can just reuse them rather than creating new ones over here. All right. So that's how we would we would represent a rat. Now, let's say we have to store information for multiple rats. So in this case, multiple rats would be called mischief. A mischief can be either a single rat or multiple rats, and the topmost rat is their leader and the remaining rats are the followers. So that's essentially the data that we are kind of designing. So in this case, we would need a structure. We would have a defined struct mischief that has the top, or I'm going to call it the leader, and the followers. And in this case, a mischief is one of, it's going to be either a single rat or it's going to be a make mischief rat mischief. And so in this case, the base case is just a single rat. The recursive case is we have a make mischief where we have the example of a rat followed by a mischief, where the mischief can be either the single rat or it can be another mischief. So it can have multiple rats in a way. All right. Couple of examples for this. So the base case would look something like this, right? Where we're just kind of saying that, okay, there is a rat, which is a base case. And the other example would be something like define mischief one, which is a make mischief with rat 2 as the specific rat over here. And in this case, we can use like rat 1. So this is an example with a single rat here, as well as a mischief, which is a rat. Another type of example we should have is mischief 2, where we have, let's say, a make rat so we have a rat followed by a mischief. So it's going to be this specific mischief. So this gives an example of a rat followed by a mischief, where a mischief is another make mischief where it has 2 rats. And so if I run this specific thing, what have I done? Oh yeah, it needs a time. Sorry, my bad. I'm just gonna give it time-1. So if I do miss2, it gives me a make mischief with where the first rat is this one, followed by another make mischief where the first rat is this one, followed by a final rat, which is like the base most case. When defining constant, should we use between the name and the number, or use no spacer? The professor uses both. It usually doesn't matter if you use the dash or not. The only thing I want to mention, which I think I didn't follow when I was writing up the code, was I started using like smaller, not smaller, sorry, lowercase letters. So you just have to ensure that when you're writing constants, all of the letters are all uppercase, so everything is capitalized. But apart from that, the dash or the space, dash is fine. You can't put a space, because the moment you put a space, it indicates that you're defining time as 2, and then you just have an extra make time. So you don't want to use space. You can have like this kind of a thing, or this kind of thing. That's fine. But don't put spaces, because spaces indicate different things altogether. Okay, yeah. So that's the example for the mischief. Then the next thing we're going to do is going to write a template for mischief, right? So mischief template is going to take in a mischief, and we don't know what the output is going to be. So we're going to have the unknown output type, right? The next thing we do is we do a define temp that takes in a mischief. And since this is the union style data, because it consists of a rat and a make mischief, we know we have to use a pond over here, right? With 2 specific cases. So in first case, we're checking if it's a rat. And if it's a rat, this is specifically defined in its own data structure way, right? So we would just do rat dash template on this mischief. The other case is a make mischief, right? And the way the thing we spoke about over here was, if at any point it's like a make salaried or a make hourly, we have all of the selectors over here, right? So what we're going to do is we're going to check if mischief, and then we do an open call. We know the first thing is going to be a rat, so we know we have to call the rat template onto the mischief dash leader of the M. And the next thing we have to do is call mischief dash followers of the M. And since this is of the type mischief, we will recurse back onto this specific template, right? So we would have miss dash template of this specific thing, and we will close off all of the brackets, and that's kind of what we do. Okay, looking at the questions, if you all have any, okay, sorry, that was any. Uh, would it be possible for these racket files you're working on to be on posted on Piazza? Yeah, so I will. Okay, let me just recap. Any code that I am writing in terms of like all of these custom like slides and stuff, I can post those because those are taken from like, in a way, like public sources. Like I just base them off of previous labs, so that's fine. The exam code that we write, I am not 100% sure if we can share it on Piazza or not. And so I will take permission before I share those. And if we can't share those, then we won't be able to share the practice exam answers. But in any case, you should be able to receive these answers and kind of go about that. Style does not say anything about constants other than that it should be caps. Okay, let me just cover all of the style elements as well, just in case it's not mentioned. So if you're dealing with a data type, the first letter is always capital. Um, and as well as, or not just first letter, but first letter of every word is always capital. So let's say if I have like that, the R is capital. And let's say if I have something like salaried employee, the S is capital and the E is capital over here. If it's a function name, then all lowercase. So like miss dash temp is all lowercase, make rat is all lowercase, and similarly like structure name in struct definition. So the structure name, which is like mischief over here, these need to be all lowercase in the definition, but obviously a capital M when you're defining the data type. The third thing is, what was the third thing? Constants. Constants. All caps. So these are just the naming conventions. I don't think David and Ryan, are there like anything else that I'm missing out? I think these are the only ones.
Yeah, I mean, I think that looks good.
Okay, yeah, cool. So those are the only three ones. I don't think there's anything else, but if something does come up, I'll definitely like update the files as well. What about examples? So examples, since they're kind of like constants in a way, you should have them like all caps in a way. Yeah. Function names are separated by dash when there are multiple words. Oh yes, sorry, I did forget that. All lowercase separated by dash. So example, I guess, is calculate and calculate. Let's put them. Yeah. All right. So yeah, those are pretty much all of the naming conventions that you need to remember. Why does this keep doing this? Okay. So the next thing we have to do is, given a mischief, design a function to reset the minute and the seconds of every rat's feed time, right? So we have a rat, we have like multiple rats, and given like mischief 2, every rat needs to have the R same, but the minutes and hours change to 0. So essentially what we would do is, um, let's say the function is called reset mischief. It's going to take in a mischief and it's going to output a new mischief, right? Because all we want to do is like return the same thing, but the time is different on every one of them. And so I'll just copy the template down so that it's easier to edit. This is going to be called, oops, sorry, I skipped over. Check expect. If it's reset mischief of rat2, we are essentially gonna get we're gonna get the same rat, but this and this changed. And similarly, and let's say if I give it a mischief, I'm gonna get this specific mischief. With both of the times reset. All right. So those are the two check expects that we would have. If it's a rat, we know we just need to call the rat template. If it's a mischief, we need to call the rat template onto the mischief dash leader. And we need to recurse onto this function for all of the followers. And the other thing to note is that since we are returning a make mischief, our function over here should be able to take the current rat and add it onto a list of, sorry, not a list, I mean, the mischief that we already have, right? So let's say if we're dealing with like these two rats over here, it should be able to take the rat and put it as the leader of the other rats, right? So the function we would be using to make a new mischief is make mischief over here. Yep. And so this will essentially make the rat the leader of the remaining mischief followers. I'm going to go with a function called rat reset that essentially takes in a rat, gives out a new rat. And so we can use this rat reset helper function over here as well as over here. And the purpose of this function is to reset a rat's feeding time. So a couple of check expects would, I mean, it looks similar to this. So we, instead of the mischief thing, we're gonna have rat reset of rat2. And similarly, I can have rat reset of rat1, whose name is Bob. And I think the time is just 1. Those are my two tests. And essentially what I would be doing over here is I'll be copying the rat template. Did I not make a, okay, sorry, I skipped on the rat template. So I'm just gonna write the function. So we have define rat reset that takes in a rat. And since we have to return a type of a rat, we know we would have to do make rat, where the name stays the same. So we do nothing on top of the name. And the time needs to get reset, right? And since the time is a structure itself, we're going to have something like time reset onto rat dash feeding time, rat dash feeding time R. And so we know we need another helper function which just essentially like resets the time. Yeah, so just to kind of save on time, I'm just going to write the function itself, which is the time reset function that takes in a time. And essentially we need to give it a new time, right, with the same R. But since we are just resetting the minutes and the seconds, we would just return 0 and 0. So, sorry. Set takes in a time, gives out a new time. And the check expect would be something like time dash reset of time dash one, and time dash one is, what's R1? Okay. It's going to be a make time 111. So the output should look something like 1. What did I do? Yeah, I don't have a rat temp, and that's what's giving me an error. Let's check that. Mischief dash follower. Oh, I have used followers. Yes. And time dash R. This function is not defined. Why is it not defined? Oh, I have used R. Okay, all of the tests pass, which means when I gave it these mischief, it was able to like successfully reset all of the times and create like new mischiefs. Okay, I'm gonna take a pause over here. Can you explain / list out your thought process for how you knew how to make two helper functions? Yeah, so the way I thought of it is, we know a mischief is going to be a rat or a make mischief rat mischief, right? And I looked at each of the data types. So rat is not an atomic data, right? Rat is a custom data that we have made. And so I know that I need to call a helper function whenever I'm writing a function which calls onto individual rats, right? Similarly, when I go back to rat has a template where it has a string and it has a time. String is an atomic data, so I know I don't need to break it down further. Time is a custom data type again, so I break it down even further and call the template for a time. And so when you keep looking at all of the template calls you have, you will get to understand that, okay, those are the points at which you need to have like helper functions to kind of help you out with like a smaller problem. So at any given point of time, you want to ensure you're breaking it down to smaller problems and solving those smaller problems rather than trying to do everything in like this one go. Yeah, hopefully that answers it. I'm still confused about the times. How does it know how to reset exactly the minutes and seconds and not the hours? Okay, got it. So when I do a make time, right? So let's say if I do time dash HR of time dash one, right? It gives me one because time dash one is a make time 111, right? So what I'm doing is I'm making a new time completely where I'm extracting the R information, which means I'm extracting this one. But what I'm not doing is I'm not extracting the other information. I'm just giving it 0 and 0. So at any given point of time, it's going to do something like make time of time dash HR time dash one, where we know that, okay, this is going to be one, right? And it's going to do 0 and 0, and it's going to make a time which is 100, right? But if I use the time dash minute over here and time dash second instead of the 0, it would essentially just create the same time itself and not reset anything. I hope that kind of clears it, but if not, like feel free to like follow up on that. Okay, perfect. Any other questions before I move forward with lists? Okay, if not, let's move on to the lists, which is like the final thing before I move on, like I pass it to Ryan and David to cover the exam. So as you kind of saw, the recursive structures are kind of like similar to lists, right? Both have a base case, both have two things within a structure, which is like referencing the first element within the structure. And then you have like the call to the remaining structure, right? And nothing is computed until you reach the base most case. So until you reach the first, like the last rat that is in the list, the function is just running, and not computing anything. So one of the questions is, why do we really need lists, right? Why can't we just keep using recursive structures? The reason is all of these recursive structures are not built-in structures. Lists are a built-in racket function. So you don't really need to define the cons part, the first part, the rest part again and again. And you can potentially just avoid like all of the data recipe for like writing what a list is. The second thing is it can be used for like any type of data. So like in this case, I can't like, if I do um, first of the mischief, it's always going to be of the type rat. But lists can be kind of generalized into any type. Like I can have a list of strings, I can have a list of salaried employees, I can have a list of rats. Uh, in addition, they have like pre-built functions that you can use to kind of do various tasks. So like, let's say if you want to calculate the length of the list, I can just do length of that specific list rather than going recursively and computing for every element it has. And in the future lectures, you're going to learn more about abstraction. So it allows you to like use like functions such as fold-r, fold-l, and all of those things to make your life easier rather than writing big chunks of code. Just in case anyone gets worried about abstractions, it's not there on exam one. It only covers everything up till lists. Cool. So what we're going to do next is we're just going to use the same mischief recursive data structure, and we're going to write a mischief that is now a list of rats. Right? And so you can assume that a mischief has no rats in the base most case, and we can start off by reworking the example. So if I was to do that, I would say that a list of rat is one of will be either empty list or it's going to be cons of rat onto a list of rat. How do we know when to use recursive structures versus a list? I guess it depends on the wording of it. You can kind of go for both, but unless we specifically say that design a list, you wouldn't have to design a list. You would have to do like a recursive structure. And in most cases, I think the exam will not ask you to make recursive structures. They'll provide you a recursive structure, and then from that point onwards, they'll kind of like tell you to write a function. But assuming like there was a question to design a data for a mischief, both options are a good way to kind of go about it. Like if um, like both of them represent multiple rats, and so you can do it. The only differentiating factor is, let's say if I said the base most case is rat, right, you would kind of go with a recursive template because over here the base case is rat and not empty list. But if they asked you that write a data definition to represent 0 or more rats, then you would want to go with like a list sort of definition because empty list indicates 0 rats, and then cons is like 1 rat, 2 rat, and so on and so forth. Is a list of rat considered a new data type? In a way, yes, because we're kind of making like a list of rat over here, and that's why I was writing the data definition and moving forward with that. Would we lose point for minor changes in the style guide on the exam, like punctuation changes in the design recipe, such as one semicolon or miss dash here and there? No, none of us are gonna deduct for like semicolons and like these dashes. In fact, like at points, let's say even if you forgot these parentheses, but you kind of got like this function right, we would award the points. We wouldn't deduct for like um we wouldn't deduct for like parentheses and small things, but let's say if you did something like make salaried here, that would count as a deduction because you're just doing something which is like completely wrong in a way. So yeah, small things like that, not as much. Big things like getting the function wrong, yes, that would be a deduction. um okay, moving forward with this. So interpretation presents, and example is define empty rat. That is just going to be empty. Define lor1, which is going to be cons of rat1 onto the empty rat, and then define lor2, which is going to be cons of rat2 onto lor1. And those are the examples. The template would be something like define lor template, which takes in a list of rats. Then we have a cond because it's like a union style data structure with two specific things. In the first case, we check if it's empty. If it's empty, we don't know what to do with it yet. If it's a cons, we know that we need to do something on the first of LOR, and we need to do something on the rest of LOR, right? And so when I look at the first of the list, the first of the list is a rat, right? So since it's a rat, it can be broken down further. So I want to call rat dash template onto the first one. And when I look at the rest of the thing, it's again a list of rats. And so we have a template for list of rat, which is this one, right? So we just do LOR dash template onto the list of rats, the rest of the list. And so that's our template. And essentially, if you had to design the same function of rat reset, so we're gonna go with rat reset, not rat reset, sorry, this is called mischief reset. So mischief reset will take in, let's say, a list of rat, and it's again going to give out a list of rat, right? Resets every rat's feed time in a the check expects would be something like check expect. We would have the mischief reset function. The base case is going to be empty rat, and the empty list would give us an empty list in return because we're returning a list of rats. Otherwise, what we would be doing is we would have LOR1 and LOR2. And so LOR2 is not yet defined. Yeah. So LOR2 is going to be this specific thing with the numbers changed over here. So this is going to be 0 and 0, as well as this is going to be 0 and 0. And I'll put it underneath. And similarly, LOR1 is going to be this specific thing with both of these numbers being 0 and 0. So when we design this specific function, we can copy the template. We can have miss reset as the name. It will be replaced over here. So if it's an empty list, we return an empty. In the cons case, since you're building a list of rats, we can just do cons over here. And one of the best things is, since we already defined a helper, which takes in a rat and returns a new rat, in this case, it's called rat reset. We can essentially just call the same helper function, which helps us do the same thing. And if I run this thing, all the tests pass. So in this case, the rat reset takes the first rat, resets the time and returns a new rat. And then that's const onto remaining elements of the list. Does that make sense to everyone? Or did anyone have any questions on what I did with the rat reset stuff? Okay, if not, I think that's pretty much the end of my presentation. What we're going to do next is I'm going to stop sharing, and Ryan and David are going to go over the practice exam, and we'll follow it up with some exam advice, and then we'll end the session over there. So I'm going to pass it on to Ryan and David. Let me, yeah, you should be able to share.
Well, I'll just go over question one, the first one now. Share screen. This one. Is my screen visible? The Racket window? Oh, wait, yes. Okay. Cool. So here we have our first question, which is your favorite store is having an end of season sale. And basically we just want to make a function that takes in a price and then also takes in an additional discount and calculates the final price for it. So looking at this problem here, it talks about the function a little bit, and then it also has this additional part where it says the store has also issued coupons with a mystery discount, either an extra 10, 20, or 50% off. So there, whenever you see something like this is one of this, or that, usually that's an indication that you want to design data. So we're going to do just that for the discounts here, because it's telling us that our function has to take in one of these discounts, and they can only be 10, 20, or 50. They can't be like 30. So I'm going to say a discount is one of 10, 20, and represents. And now I'm just going to follow the data design recipe and define examples for all of these. So I'm going to do discount. Oops. There we go. We have our 3 examples for our 3 different cases. And now we're going to make our template. So always with our kind of enumeration templates, where we have one of this, that, or another thing, we're going to use a cond and split up each branch of the data. And we're going to have a different case for each of them. So I'm just going to call this discount template. I'm going to take in a discount, which I'll call that. And then, like I said, I'm going to use a con. So we know since there's 3 discounts, we're going to have 3 con branches there. And kind of similar to the string enumerations we've seen before, but instead of using string equals hom, we're just going to use equals. And this will compare the discount we're taking in, which is D, to each of these examples I created. And this should look pretty similar to some of the ones you've seen in class. I know you don't usually do ones with numbers, but they're pretty much the same as strings, except you're just working with equals instead of something like string equals 10. But this satisfies the discount part that's specified here, the 10, 20, or 50. So we're all set there. And I'm just going to note that I did these as whole numbers because it said as a percentage. I guess you could do it like 0.1, but just because the problem says it's a percentage, it's probably better to keep them as whole numbers. Also, I didn't do something like 10% because we can't actually define that in the bracket. Now for the actual function. So I'm going to start off by showing you how we use it using the template, and then I'm going to simplify it down. So let's say starting with template. So we know this function is going to be called, let's see, what's the name of it? Final sale price. So I'm going to write my signature here, my function name. And I'm going to say this function is going to take in a non-negative number and a discount. I'm going to output a So here I chose to use non-negative number because this is going to represent the price. We can't have a negative price. I guess theoretically something could be free, which is why I wanted to include 0 in there. It could also be a decimal amount, which is why I didn't say it had to be an integer. But yeah. And then I also have it taking in the discount, which we just defined up here. And then it's going to output another number right there. I'm going to say for my purpose, takes 20% off. With the additional discount. And now, like I said earlier, I'm just going to take the template here and put it in. I'm going to rename it. And this will be our price here and our discount there. So now for each of these branches, we're just going to go through them and see what they'd evaluate to. So because we want to first take off the 20%, we're going to do times 22 to the price. And then after that, we want to ensure that we're actually getting 80% of the price. You could do times 0.8 of the price, and that would be fine too, but this accomplishes the same thing. We're also going to subtract from that the discount divided by 100 multiplied by the price. So here we have our original price. We're first subtracting the 20% off of it from the original price, and then we are subtracting the discount divided by 100, which will leave us with a decimal value for like 0.5, 0.2, or 0.1. And we're going to subtract that from the price too. This is going to be the same for each of our con branches. And one note I want to make too is that this is assuming that the discounts are, the additional discounts are taking off the original price. Some stores, they take the discount off of the sale price, so it's a little bit less. You could interpret it either way. It doesn't really specify it in the problem, but both ones should be valid solutions, and you can solve it either way. Yeah, for here, I'm going to write some check expects too. So if I do check expect price, and then I do it on 10. 7. I guess I'll do 0 because I did say something could be 3. Do 20 and 20 there. That should be. And if I run this, hopefully everything should work. Cool, so all 3 of the tests passed. But like I said earlier, this isn't the simplest way to make the function. So I'm just going to make a v2 down here. So if you notice, we use the same exact result for each of these con branches. So what I can do here is just get rid of that con entirely and just have this clause right here. Because it doesn't really matter what discount we're applying because we're still performing the same operations. So that would be v2 there. And then if I wanted to check that, I'll just change these to v2. Run it. Cool, all 3 tests passed again. This is turning red just because I changed these to v2. Yeah. Does anybody have any questions? Wait, let's see. Yeah, I see some questions about the simplifying. I hope I answered that right there. You could do the 0.8 too, that works.
So just to like clarify, the only reason we did the first way is to kind of just follow the template that we had made in the previous example. But the second one is obviously a better one because you're doing the same thing for all of the 3 conditions. So you don't really need any conditions and you should simplify. Yeah, so between both of them, the second one is a better choice. The first one was only done to ensure that you're following like the template.
Yeah, exactly what Harsh said. You want to get into following the template as much as possible and then seeing where you can simplify afterwards because it's much harder to go from something that doesn't follow the template to something that follows the template rather than the other way around. Are there other questions? Are the discounts additive or multiplicative? So here I did it so they were just based off of the original price no matter what. It doesn't really specify in the problem, but it would be easy enough to design one where it is based off of the result price. Yeah, exactly. Can you just, yeah, you could do that. You could do that with our current implementation. You could just kind of add them together. So it'd be plus discount plus 0.2, and that would work too. This way just kind of shows like the math out a little bit more. Does anybody have other questions? Cool. So David will go over question 2, and then I'll go over question 3 afterwards. Let me stop sharing.
Okay, yeah, so can y'all hear me? Okay, I had a bit of audio difficulties here, but I think should be good now, hopefully. So let me know when y'all can see my screen here. Get started on problem 2. We all good? All right, cool. So this problem, so I know there were some questions before about like when we should use like the data design that has like structures defined separately, or sort of like the structures defined like all in like one in one data definition. And so, like this one, there might be questions where they give you something like this, so you have to know how to deal with it in both situations. So I would definitely study both of those for this exam, because you never know, even if you say, okay, I'm probably not going to use this data definition or do it this way, they still might have something like this on the test. So you'd have to know how to work with this. So so we know that arrangement is the data structure we're working with here. And it can be either a string, make port side with arrangement, then string, or make starboard, string, then arrangement. So I'm guessing a lot of y'all, when you probably first read this, didn't really know what port side or starboard was. I mean, I didn't really either. I had to look it up. Apparently it has to do with like ships and stuff, but that's not really like important for this question. You're not expected to go in and know what this is. You're just expected to be able to, take this like data definition and be able to work with it and make, functions and other parts of the design recipe. And that's also why they don't really ask for like an interpretation here, because they're not expecting you to know what all this like random stuff means. So yeah, I guess we can get started with the first part here. Give 3 distinct examples of arrangement. So in this case, since there's like 3 possibilities for this data, it would make sense to make like examples for each like type we have. So I'll start with string, and string is very much like our base case here, because that's like the only one of these where it doesn't really recur. So I'll just call this like base. And then don't get like in this exercise, I wouldn't get too worked up over like what to put for string. They don't really tell you. So as far as what we care for when we're designing the data, we can kind of just have like anything go. But like Fundies, for example, that'll be our string. And then let's make an example for port side. So call this PS1, and we'll do a make port side. And we need an arrangement to reference. So we made one right here called base, so we can use that. Base is an arrangement, because a string can be an arrangement. And then we'll have another string. I don't know, just say like hello or something like that. Doesn't matter too much right now what the strings say inside these. And then make an example of starboard. And so that will be a make starboard. I just have another random string here, and the arrangement will reference our port side here. So now if I run these sort of, let's see. Oh yeah, I didn't define the structures. Let me make sure that's in the code here. Define struct port side s, and then define struct starboard. So yeah, assuming those would be in the code there. If we run something like SB1, we see that it consists of the first element, which is the string, the second element, which is this whole structure, the port side, and the port side, the first element is what we have for the base, and the second element is just the string we put here. So we could have like more complex examples of this. So if we had like, let's say we made a starboard where, or no, we'll make a port side. And instead of using like base here, we'll put the first value to be SB1. And then the string be the second value. And then if we run that, you'll see that it gets a lot more complicated what's going on here. We have this as like the first value of the port side structure, and then this is the second value. So you can see that if you make like compound examples, this data can get really complicated to read really quick. So that's why for B, we want to make a template for this data, because that will help us worry about C, which will be dealing with this data structure. So we have our examples. let's make the template. So call this like R temp A. So we know its union data is one of, so we're going to have a con with 3 branches here. All right, so the first case is going to be string. And now, of course, for this one, we don't know what the string would be, so we can't really put string equals. But like Harsh was saying earlier, let's say we did know what this was. It said it was like an empty arrangement or something like that. We wouldn't want to put string equals empty arrangement, because if we had a function that used that, and let's say we put port side 2 into that, it would give us an error because it can't, string equals can't take in other values that aren't strings. So for these, we always want to check the type here when it's like this kind of union data where it's string and then other data types. And then, so after here, we'll just put some ellipses because we're not really sure what we want to do with that yet. Second case is going to be if it's a port side. So if it's port side, what we want to do is access the different fields of port side. So we know we have port side, let's see, so port side stream A, and then we fix the indentation here. You have port side, port side stream A, and then port side, what is the other part? SA, which is the string. And so now, before we move on, we want to sort of look here at, when we get the values out of this, what is it exactly that we're dealing with? So port side SA is a string, so we don't really need to do anything extra with that. But port side stream A, if we go look up here, we can see it's an arrangement. So arrangement is a data type that we define. So we're going to have to call another template on it. So for this, it would be the arrangement temp. And then, of course, that's where our recursion is going to be when we design our function. We'll get to that part later. And yeah, so then we'll do the last con branch here, which is starboard of A. And one quick thing about this is you could, while it would technically work if you put like else in this clause, we want to stick with like just having predicates in these con branches so that like we can, it's easy, it makes it easier when we're writing the code. We know exactly what to expect here. If it's a port side, then we do this. If it's a string, we do this. If it's a starboard, we do this. Else can make it harder to debug. And I know else, it may seem like it makes more sense because it prevents the program from erroring. But if we have like some sort of input to this function that isn't like already one of these, then at that point, we would probably want to throw an error and stop the program because, that's not like a data type we would expect. And, let's say we did put else here and then started trying to like do stuff like the next part, like starboard, SA, then if it wasn't even starboard, then this would give an error anyways. So whenever you're doing like templates or union data like this, I would definitely recommend putting predicates in these, like not using else and using predicates for all these. Now, of course, when you're doing like some functions, like let's say stuff with key event, you'll need to use else, but generally in these kind of questions and with the template, you'll want to avoid using else in the con branches. So we have to starboard, we want to access the parts. So we have S and then stream. So we have here starboard SA, and then our next part is starboard, stream A, right? Yeah, okay. Again, we want to look at our types. is a string, so we're fine just leaving it like this. This is an arrangement, so we need to call arrangement temp since that's a data we've defined. And let's see, I'm missing a parentheses there. All right, and then that looks good for our template for arrangement. Let me check the chat, make sure we're all caught up here. Yeah, okay, it looks like Harsh has got all the questions. Yeah, feel free to unmute if there's anything else.
Yeah,
Yeah.
just to kind of answer the question, why can't we use else? You can do it, it's fine. The only reason we didn't do it is because we have these 3 data structures and we kind of just like want to follow that. And one of the things, one of the reasons why not using an else is better is assuming you gave it like data which is not one of these arrangements, else would try to like still work with the given data, because like let's say if it was string starboard or sorry, string port side starboard, and I gave it a number, in the else case it will try to use the number onto the starboard template, versus in the 3 predicate cases it would just say that all of the conditions resulted in false, which means that your input is kind of incorrect. So in like both would give errors. I usually just prefer the one which says all the con were false, because then I can just review why it was incorrect. But you can go with like both options, that's fine as well.
Yeah. Yeah, so that's, yeah, usually when writing templates like this one, it's better to stick with predicates instead of using else for a lot of those reasons. I also think this is just more readable. Like you can kind of more tell what's going on. Like, okay, here I expect it to be port side. Here I expect it to be starboard. If you use else, you kind of have to like check here, figure out which data you're not using. But yeah, yeah, that's why usually not using else is better for the templates. So let's move on to the part C. So define a function that takes in an arrangement and a string. Returns true if the arrangement contains the string and false otherwise. So they didn't really give us a name for this function, so we should call it like contains string, and so we're taking in an arrangement and a string, and that is a Boolean. The purpose statement. So again, we want to avoid saying stuff like in the purpose we want to avoid in the purpose statement saying stuff like takes an arrangement and looks at the string, checks it, because we don't want to rehash what we said if what we said in the signature. So a good purpose statement would be like if we say like determines if the given string is in the arrangement or not. Something like that, where we're more getting down to like what is the point of the function. So next up, we want to write some check expects. So check expect string let's do base, and we need to also give it a string. So we'll give it fundies, and we know that will return true. Check expect contains string. Next example is for side 1. That one will check something it doesn't have, like hey, and that should return false. And so we know this will use the template. I'll go ahead and just copy that down here. Since we know this will use the template, this will have like a con with 3 branches. So we'll probably want 3 check expects, because when we're writing check expects, we want to make sure we cover like all the different con branches. So contains string. So we did base port side, so we need a starboard example. Do SB1, and we'll see, does it contain hey? Which it does. Okay, so now we have our test, signature, purpose statement. So we're ready to start writing our template. So in the string case, all we want to really check is the string equal to, oh, sorry, we have another input here. So S, is the string equal to S? If we have a port side, so for our temp, we want to use contain string because that's our recursive step. And remember that we also need to give this S as an input to the function, so we can keep track of the string we're comparing. So we know that this will output a Boolean. And so, okay, yeah, so first let me move to the next part, which is port side SA. We want to know if string equals that to S. And now we have these two things that will evaluate Boolean expressions. So in this case, we want to know if the string is in the arrangement at all. So for here, we can just use an OR statement to combine these together. And then let's do starboard. So this will be pretty similar. Contain string for here. We need to carry the S around with us too. Here we want to see string equals starboard SA with the string we have. So we have these here. So lastly, we need to just put an OR statement here and make sure our parentheses are good. Yeah, okay. So now if we run the function, let's see, cond, I may have messed up some. Yeah, let me put this here. So, okay. Yeah, so looks like our function ran. Yeah, it looks like it didn't get to use the starboard example since it got here and this was true. It didn't get to use like this part of the code. I guess if we wanted to fix that, we could put something like fundies there. Now if we run it, we won't get that color there. But I think the important part with this is making sure your tests cover each like cond branch here. So yeah, any sort of last questions about this part? If not, I think I'm ready to hand this off to Ryan so we can do the last part of the last part of the practice exam.
So Ryan, do you have to go or are
you? Yeah, I'm gonna have to go at like 8. So I have like 5 minutes. So I don't know if I should.
Yeah, I think I can cover it. That's fine. Yeah.
Cool. Did you get the message I sent you?
Yeah. Okay.
Cool. Thank you.
All right. So the third one, let me start sharing my screen. Okay. So the third one is we have like a defined structure of applicant, and we are saying that an applicant is a make applicant where it's the name is the string, the number is the age, the Boolean is if they are a professional or not. And then we have like a recursive data structure where we are saying like a list of applicants is one of either empty list or an applicant followed by a list of other applicants. And so one of the things you would have noticed is like example templates are kind of missing in this. You don't really need to make them because those are not required here unless we are specifically asking you to. I'm just going to make a couple of examples for the applicants because like I can use them for like check expects and so on and so forth. So for applicants, I'm going to have like, let's say Bart as an applicant who's 10 years old and he's not a professional, Lisa as an 8-year-old who's a professional, and Homer who's 35 years old and is not a professional. And Similarly, if I was to make examples for a list of applicants, I would have like a base applicant where it's just like empty. Then the first list is just like adding Homer onto the base, adding Lisa onto the Homer list, and then Bart onto the remaining list. So if I run through this and if I put LOA3, I would get a list of Bart, a list of Lisa, and a list of Homer. And the template is usually going to be something like this, where it's going to look similar like the rat template, where if it's empty, we're doing something. If it's like a cons element, then we have to call an applicant template onto the first one. Otherwise, we're just going to recurse onto the remaining stuff, right? And the next thing we're kind of doing is designing a function where we're checking which people are eligible for the contest and then returning that specific list. So the function, I think, is called eligible contestant. Yeah. So it would take in a list of applicants and it would give out a list of applicants, right? Because it asks us to filter out those that are not, that are, sorry, I forget the criteria. David, can you remind me what was the criteria for the thing?
Yeah, wait, sorry, let me check.
I think it's filter out under 24 and those who are on false, right?
Yeah, if they're are they eligible if they're under 24 and they must not be working as a professional software engineer.
Yeah, okay. So the age should be less than 24 and the participation or the professional half field should be false. Those are the two criteria. So if we follow this specific template, oh, sorry, let me do the other parts of the design recipe. So filters out a list of eligible applicants. And so what
I think the question is also it's not filtering the list, it just counts like how many in the list are like eligible. So output is just like a number.
Okay. Are you sure about that? Because I just don't have the paper open on me, so I just want to confirm.
Yeah, yeah, I got it. It's like
Okay.
Yeah.
Cool.
Or like a pause, like pause in or non like number or whatever. Yeah.
Yeah. All right. So it filters out a list of eligible applicants and returns the count. So if I write a check expect, I'm gonna call this specific function. It takes in, let's say, the base case. And since an empty list has no potential applicants, it's going to return 0, right? And similarly, I'm gonna have a couple more examples. So let's say if it's LOA1, we have Homer. Homer is 35, so he's below the 24 age. Sorry, he's above the 24 age, so he's not a potential, he's not eligible for the contest. So we are still going to stick with 0. In this, we're going to go with LOA2. Lisa is under the 24 age, but she is considered a professional. So we're going to still stick with 0. And LOA3 has Bart. And since Bart is under the age of 24 and is not a professional, he is eligible for the contest. And so we have like a list of like couple tests that we can run. The next thing is the code part. So we'll copy the template and we'll change the name of this thing. So if it's empty, we know we want to do a 0. If it's sorry, in the other case, what we want to do is we want to call a function, a helper function for the first of the applicant, and then we want to recurse onto the rest, right? So let's say I'm going to go with the function eligible huh, right? And this eligible huh function will take in an applicant and will either return 1 if they are eligible, or it will return a 0 if they're not eligible, right? And so if it's going to return numbers and this thing is also going to return numbers, I want to add them up. So I can just use a plus over here. The next thing I would do is I would write the eligible huh function. So I would have eligible huh, which takes in an applicant and returns a posit. And essentially the count of so couple of check expects would kind of be like check expect eligible huh. Let's say if I give it Homer, it should give me 0. And similarly, if I gave it Bart, it should return 1. So that's what the function looks like, right? And so in the actual function, what we're going to do is we're going to have the define, we're going to have eligible huh, takes in an applicant, and we want to check 2 things. We want to check if applicant dash age is less than 24, and we also want to check if the applicant dash, I think professional huh, is false, right? So only if it's false, then we should return a true value. And so in this case, what I'm going to do is I'm going to do a not on top of this, because if it's false, it will return true. If it's true, it'll return false. And I can combine it using an AND expression. So this would essentially indicate that if the application age is less than 24 and they are not a professional, then only like return true. Otherwise, the entire thing will return false, right? And so the next thing I would have to do is I would write an if expression to specifically see that if both of these criteria meet, right? I would, if both these criteria meet, I would return 1, else I would return 0. And that's kind of what my function would look like. So if the applicant age is less than 24 and they're not a professional, return the count as 1, otherwise return the count as 0. And then all of these kind of get added up over here. And so hopefully when I run this, what did I do wrong?
I think you need a parentheses in the if, and then applicant age, and the other ones need like the A inside there or whatever. And yeah, I think those are like mistakes. If you did that on the exam, I don't think, that's stuff we would count off for, but that's like examples of like small things. Like, we understand, the code, but it's like, of course, if you run it, it'll like not work or whatever. So yeah.
Yeah. So could you return a Boolean with eligible huh and do the adding in eligible contestants count? Yes, you could actually do that as well. So you could essentially do like, I'll just copy it down so that I don't change the first version. So you can do something like, I guess if eligible, then do something like add 1 onto the recursive count. Otherwise, just do the recursive count. So that's the other way you could also do it, assuming your eligible function is just returning a Boolean. So, okay, what you're doing is you have a condition which checks that as false. So, okay, got it. This specific code, it's fine in a way. The only thing is you're kind of like it can be simplified further in a way, because this entire expression that you have over here is going to give you either true or false, right? If it's true, it's going to give you true. If it's false, it's going to give you false. So you could have kind of like simplified it by just doing something like this. And so if you just did that, you would kind of like simplify it further while like doing the same thing essentially. Yeah. Could you return? Okay, yeah. So I think that basically covers up all of the things. So couple of other things. So advice for the exam. The first step is obviously follow the design recipe at every given point, because there is always scope for partial credit. Read all of the questions first and try to finish the easier ones and then move to the difficult ones. Because let's say the exam has the first question itself is very difficult, right? And the rest two, three, or how many ever there are going to be are like super easy. You would want to finish off the easier ones first and then kind of tackle the difficult ones to like do maximum coverage of all solutions. If you're stuck at some point, try creating more examples and more tests, because like it gets you in the habit of like thinking about it. And remember that every step of the design recipe counts. So if you have no clue, like write whatever you possibly can just to ensure that you're getting some amount of partial credit. And we've gone over concepts, and I would say if you have not done the practice exam, try doing it before the Thursday exam. This is a slide from last semester when we used to have Wednesday labs, but yeah, just ignore Wednesday lab. And before the exam, also like review to see what mistakes you have made, so that you can like potentially solve them and understand like why you're making a mistake and how can you avoid the mistakes. The next thing is, let's say if you do have a bad exam, suppose, the first thing I would say, it's not the end of the world. Like a lot of people do have trouble with this and it is a difficult course. So I would say like, obviously people do feel bad about it, but like I would say like try to understand what you can do to kind of move forward in the future. I would say walk through the exam and try to solve it again until you get it like 100% right, so that you kind of understand what are the mistakes that you're making and you understand all of the concepts. If you're still not understanding any of the concepts in class, come to office hours or like schedule a session with like the professors, and I'm sure they'll be happy to like help you out with understanding those concepts. Don't give up. That's just what I will kind of end it off at, because so Fundies one is just like one small part of either your college journey or either your college major. And don't let this one exam or one subject kind of like feel you like let down. Like try to overcome it and like move forward with it. And I know it's easy to say, so here's what I'm going to do. I'm going to give you a personal example that I resonate with, and I'm going to do it only for the people who have stayed until now. So it's like a specific thing for you all. How do I stop recording?